Thank you. Good afternoon, everyone. So we're all familiar with all these satellites that NASA has been launching for decades, observing the Earth from the sky, eyes down on the Earth, right? And we've used these decades worth of data to not only understand the science of the entire Earth and the ecosystem, but also take the science and the data into informing real-world decisions. And the way such wide uptake of NASA data has happened is because NASA has championed the data democratization. And in my opinion, this is a cornerstone of enabling open science. Science for all, global. And so I present to you a unique project, one of the unique projects within NASA called POWER that you heard about, where we basically work with three focus community and focus areas in renewable energy, buildings, and sustainable infrastructure, and agroclimatology areas. And we work closely with these communities to ensure that they can take the NASA's satellite and modeling data sets and consume it directly in their decision-making frameworks. And there are two basic categories of data sets that we are serving these focus areas, which is the global surface solar radiation at varying temporal scales, starting from 1980s. And the other one is the global surface meteorology, basic parameters. Something happened to the figures there, but that's also going back all the way from the 1980s. So a 4+ decade worth of data sets put into the hands of end users. What we're seeing here is an animation that's showing hourly data requests. The red dots are people in a location on Earth, and the arcs are pointing to a place on Earth for which they are requesting data. So this is just to exemplify that, okay, it has a mind of its own. Okay, so basically we're showing, when whatever we're doing, that's the kind of impact. Every data that is being requested at an hourly base over here is a decision that somebody is making, and how are we supporting those decisions? How are we opening up these kind of, accessibility questions? So I want to introduce you to some of our users over here. This is Joe, and I'll be showing you some of these decisions that they're taking. He's wondering, if I adopted green energy, can I save cost? Jill is wondering, I want to take my payload on a drone into the oceans. Is there enough sunlight to power my drone? Joshua wants to know that I implemented green technologies over 7 solar siting facilities, and what is the performance? Margaret, a researcher, wants to know, if I did an intervention of adding nitrogen fertilizer, how will it change the yield of corn? And then Ben, he wants to determine the optimal solar water pumping configuration for his customers. What does their world look like? This is a decision somebody is taking, and if they were to inform their decision with real-world observations, they're going to need to understand first, what is the data that's available? Where is it available? How do I download it? Well, I need a data point for a location in the world, and turns out that Ben needs to process about 9 terabytes of data for that one decision in one location. And then, of course, they need domain knowledge in terms of the science, the data formats, etc. So I just walked you through all the barriers that we have been working with end users to understand how can they use satellite data sets in their decisions. And we've been doing it for 25 years and identified that if we know the question they're asking, we can help them identify the exact source of data. And then we talked about data authority. In our science world, we call it characterizing the data quality. And if Ben doesn't have the domain knowledge, then we need to provide that. So that completes everything that we can do to give data in everybody's hand, right? Data democratization here. Okay, now there's data for everyone. Is everyone able to access it? well, beyond the understanding the needs of the data, it is absolutely important to make the data accessible. And that is part of the next phase that we have been handling with in our project, where we transform the data, we modernized our architecture to allow Ben to tease out 35 years of data from one location in the world in 3 seconds. By optimizing the data sets and putting them into ZAR formats, which is time-optimized cloud-native data formats, and then we distribute it in several mechanisms. And so there is a user that needs the data in different frameworks. So we've got different services so that people can adopt the data. For APIs, we also give out all kinds of codes, Jupyter notebooks, for people to just take the data and use it. We have a no-code access we have developed as a service, and so people can analyze, subset, download the data sets in different formats. These communities have specific needs for certain generating reports, and that is something that you can directly do from our websites and NASA's strategic partnership with Esri. We have all our data in Geospatial feature services from, you can download from Esri's Living GI Atlas and things. Lastly, we are working on a tool to give more power to the end users in terms of validating the data themselves, to look at what the uncertainty is when in the context of the decision they're making. So by adopting all these technologies, what we have identified that when we modernized, in the last 5 years, the data uptake has grown by 10-fold. And we've got about 7 million requests coming in per month. So this is just one product that from NASA that's catering to one basic community, but that's who we are powered. So I hope I was able to give you an example of taking data from the launch to the last mile. Thank you for your attention.